So welcome again, student. I am discussing now how to prove the laws of refraction by using Huygens principle. It is almost like how we have in last lecture how I did the proof of laws of reflection by Huygens principle. Almost similar. Okay. Now here, see this figure 2. Okay. Now here, this is the means denser medium. Here we have considered light rays are coming from rarer medium or air, and it move into the denser medium whose refractive index is mu. Here xy is the separating medium, separating surface which separates the two medium, lighter medium and denser medium. Okay. Now this is the AP. This is the incident wavefront. I told earlier that. So this is not a line. This is a plane wavefront. So see, like this. This is the separating surface, and this is the plane wavefront. Okay, three-dimensionally you have to visualize. Okay, now say so. This is the plane wavefront. PA we have considered. Now MP, LA are perpendicular to this plane, normal to this plane wavefront. So these are the rays of light. Okay. Now first we have to construct the refracted wavefront. Okay. So how to construct? If we draw the spherical surface taking such that A dash equal to V by C P dash. Okay, it means when light coming from reach from P to P dash, at the same time light reaches from A to A dash. Okay, by using this equation A dash equal to V by C P dash. Here V is the speed of light inside the denser medium and C is the speed of light in air or free space. Okay, now taking this equation, if we draw a spherical surface like this, just arc, here also if we draw, then if we connect the tangent of this spherical surface, we'll get a line that is A dash P dash, and this line or this plane act as a refracted wavefront. Okay, now you just go just do these things as earlier in case I discussed how we have done in case of a reflected wavefront. Okay, so here angle NAL we have considered I, angle of incidence. Okay, it is shown here LAN, angle of incidence. Here AN is the normal on this separating surface XY. Similarly, this dotted line is also normal and this dotted line is also normal. Here, so here A dash L dash or K Q dash S dash and P M dash all are normal to this refracted wavefront. It means normal to this A dash P dash line. Okay, so these all are refracted rays. Okay, so here angle of refraction is R. Okay, so from this geometrical figure we can show that this angle also angle of incidence means PAK is I. Similarly, we can show that P dash Q dash K means K P dash Q dash equal to R. Okay, now so A dash P dash is the refracted wavefront we have constructed. Now we have to prove the laws of refraction. So just see, when it reach P to P dash, at this point same rays coming from LA, it reach A to A dash. Okay, now we have considered third ray, that is SQ. Okay, now when ray reaches P to P dash, at the same time Q, the point of incident Q on the incident wavefront reaches Q dash point via K, and it takes the same time. Okay. Now finding the time taken by Q point to reach the Q dash corresponding point Q dash on the refracted wavefront. If it is denoted by T, then T equal to QK by C plus KQ dash by, okay, KQ dash by should be KQ dash by V, should be V, okay, not C, because V is the speed of light inside this denser medium and C is the speed of light in air or free space. Now this triangle AQK is the right angle triangle, and angle QAK is I, angle of incident. So from this triangle we can write QK equal to AK sin I. Similarly, right angle triangle P dash Q dash K, we have Q dash P dash K equal to R. So from this triangle we can write KQ dash equal to KP dash sin I. Okay. Now putting this value KQK and KQ dash in equation 1, we have T equal to AK sin I by C, KP dash sin R by V. Okay. Now T equal to AK sin I by C plus now KP dash, this is KP dash. So in place of KP dash we can write AP dash minus AK. After writing this, we have got this AP dash minus AK within first bracket sin R by V. Now separating the terms, T equal to small t equal to AP dash by C sin R plus AK within first bracket sin I by C minus sin R by V. This is equation number 2. Okay. Now see, if we take another, don't need to draw this, you draw just 3 rays. Okay. For explanation, I am drawing this ray. Now I am drawing another ray, this ray. Okay. It is incident. This ray is denoted by R. This is R dash. Okay, R dash. This, and after refraction, it will move along this path. Okay, this is denoted by R dash. Suppose. Okay. Okay. Now here, when this ray hit at T dash K dash, now AK, value of AK, value of it's become AK dash, not AK. So when the point of incident is changing on the incident wavefront, then the corresponding point of a refraction on the refracted refracted wavefront is also changing. So value of AK dash is not fixed, it's not same, it is always changing. Okay. Now time taken from Q to Q dash to reach the Q to Q dash point and P to P dash point, and here A to A dash point is always same. So T does not depends on AK, because its value is always changing with the change of point of incident on the incident wavefront. Okay. So AK is different as the time taken is same. So T must be independent of AK. Now from this equation, when T can be independent of AK, if this term AK within first bracket sin I by C minus sin R by V should be 0, then only T independent of AK. So putting this condition, AK within first bracket sin I by C minus sin R by V within equal to 0. So what we have got, sin I by sin R equal to C by V, sin I by sin R equal to C by V means ratio of speed of light in the two medium, and that is equal to mu. Okay. So this is nothing but a Snell's law. So we have proved the Snell's law by using HUYGEN'S wave theory. Okay. Now from this construction also we can see that LA, Okay, L is the incident ray. A dash or A dash L dash is the refracted ray, and AN is the normal at the point of incident ray. So from the mode of construction we can say that these all are lie in the same plane. So laws of refraction are proved by using Huygens wave theory. So you just go through this. Okay, so you need to draw these three rays, MP, SQ and LA. I have drawn this R K dash R dash ray just for explanation. Okay, so you just go through all these things. Okay, thank you.